6.5, Example 3. In this video, we're going to go ahead and find the general solution to this differential equation. So the first thing you're going to want to do is get the dx to the other side. So we have dy is equal to 6x squared minus 8x minus 4, all divided by x squared minus 4 times x minus 1 dx. Okay, so we're going to want to integrate both sides. So we get y is equal to the integral. And then what I'm going to want to do is factor out the denominator. 6x squared minus 8x minus 4 over x minus 2, x plus 2, and x minus 1 dx. Now the next step is to take this piece here and break this up using partial fractions. So we have 6x squared minus 8x minus 4 all over x minus 2, x plus 2, x minus 1 is going to equal. And the way this works is you put a over x minus 2 plus b over x plus 2, and then you put c over x minus 1. So you're putting a letter for each of the denominators. And then we're going to go ahead and multiply both sides by the LCD. Okay, and if you want, you can write the terms out and then cancel them. Or you can remember that it gets everything except the term it has. So for example, A is going to get x plus 2 and x minus 1 because the x minus 2 is going to cancel off. So we get 6x squared minus 8x minus 4 is equal to a times x plus 2, x minus 1, plus b, x minus 2, x minus 1, plus c, x plus 2, x minus 2. And then the next step is to go ahead and distribute everything. Okay, so the first thing I did here was I distributed the x terms to get the quadratics. And then the step after that is I went ahead and distributed the a into all of them, the b into all of them, and the c into all of them. Okay, now we're going to set up our little equations to go ahead and solve. So the first one I look at is my x squared, so the terms for x squared. And on the left I have a 6, and on the right I'm going to have an ax squared, a bx squared, and a cx squared. So I get a plus b plus c. Now we're going to look at our x terms. And on the left I have a negative 8. And on the right I've got an a and a minus 3b. And now we need to look at our constants. So on the left I have a negative 4. And on the right I've got a negative 2a, a 2b, and a minus 4c. Okay, so now I've got systems of equations, and you can solve these by elimination or however you like. I like to solve them using substitution, especially because the middle one has only 2 letters. So here I'm going to get that a is equal to 3b minus 8 by adding the 3b over. So I'm going to take this equation here, and I'm going to plug it into this a. I get 6 is equal to 3b minus 8 plus b plus c. So I combine like terms and I get 6 is equal to 4b plus c minus 8. Add the 8. 14 is equal to 4b plus c. And from this I can get the equation that c is equal to 14 minus 4b. Now I need to use the last equation that I made. So I'm going to use negative 4 is equal to negative 2a plus 2b minus 4c. And now I'm going to use the a equals 3b minus 8 and c equals 14 minus 4b. I'm going to plug all of those in. So I get negative 4 is equal to negative 2, 3b minus 8, plus 2b minus 4, and then c is 14 minus 4b. Now just be very careful now, because now it just comes down to algebra, and mistakes are easily made. So this is negative 6b plus 16 plus 2b minus 56 plus 16b. So negative 4 is equal to, I'm going to combine my like terms. I got a 6b, 2b, and 16b. So that's going to give me 12. And then 56 and a 16 make negative 40. So I add the 40, and I get 36 equals 12b, and b should be 3. Okay, once you get the first one, I know this first one's kind of hard to get, but once you go ahead and get this first one, you just plug it into all your equations. So I have c is equal to 14 minus 4b, so c is equal to 14 minus 4 times 3, so c is going to be 2. And I have a is equal to negative 8 plus 3b, so it's negative 8 plus 3 times 3, which is going to be 1. Okay, so now I've got c, b, and a. So back to the original problem, the integral of 6x squared minus 8x minus 4 over x squared minus 4 times x minus 1 is equal to the integral. Now be careful that you line these up right? A, which is 1, needs to go over the x minus 2 because that's how we set it up. So plus 3 over x plus 2 plus 2 over x minus 1 dx. Okay, and then you just integrate. This part's super easy. We get ln of x minus 2 plus 3 ln x plus 2 plus 2 ln x minus 1 plus c. And then we just have to put them together. So the first thing I'm going to do is get these exponents up top. So you get ln of x minus 2 plus ln of x plus 2 cubed plus ln of x minus 1 plus c. And then when you put all this together, because they're being added, you're going to go ahead and multiply them. So I want to show you guys a quick little thing. It's an alternate way to solve these problems instead of distributing and then making the equations. So what you can do is you can strategically find x values that will make the equation easier. So for example, I'm going to test the number x equals 1. So what I'm going to do is I'm going to plug 1 in for x everywhere. So watch what happens. When I plug the 1 in everywhere, certain terms are going to go away. So notice that 1 minus 1 is 0. So that means that this entire term is gone. And this entire term is gone. So all I'm left with is 6 minus 8 minus 4 is equal to c times 3 times negative 1. So 6 minus 8 minus 4 is going to be negative 6 is equal to negative 3c. So I get c is equal to 2. So I do get one of the values much faster, but then you have to repeat this process by using other x values. So the next x value I'm going to try is negative 2. And the way I'm getting that negative 2 is I'm taking one of the terms, and I'm figuring out what will make it 0. So when I go ahead and plug in negative 2, I get this equation here, and you'll notice how this term and this term are going to zero out now. So these are zeros. So now I just have to solve it for b. So I get this is going to be 6 times 4 plus 16 minus 4 is b times negative 4 times negative 3. So 24 plus 12 is equal to 12b. 36 is 12b, so b is 3. And then you just have to try it for another x value, so we go up to the top. And this time I need to get the last one, so I've tried 1, I've tried -2, so now I'm going to try 2. And I'm not going to bother writing the rest of them because I know they're going to zero out because the 2 minus 2 is going to make 0. So here I get 6 times 4 minus 16 minus 4 equals 8 times 4 times 1. So 4a is equal to 24 minus 20. So 4 is equal to 4a. So a is equal to 1. And then that's another way you can get your a, your b's, and your c's. And this will work instead of using the linear systems. So it's up to you which way you want to do it.